Welcome to Summarize Science, where complex research is broken down for everyone. Today, the focus is on a fascinating study about why large language models often fail at following step-by-step instructions. It is often observed that AI gets the right answer, but this research asks if the AI is actually doing the work or just taking shortcuts. To test this, researchers from the Indian Institute of Technology created a special math benchmark. Instead of hard math, they used very simple operations, but stretched them out over many steps. They wanted to see if a model could stay on track for procedures involving up to 95 steps. The team evaluated 14 different AI models to see how scale and thinking abilities influenced their performance. The results were quite surprising. As the number of steps increased, the AI performance plummeted. On average, accuracy dropped from 61% for short tasks down to just 20% for long ones. This shows that even if an AI is smart, it has a hard time maintaining focus over a long period. One major hurdle identified was something called look-back dependencies. This is when a current step requires information from a variable created many steps ago. As the depth of these dependencies increased, models struggled significantly to retrieve the correct data. The researchers found that many models suffer from under-execution. This means the AI simply gives up and provides an answer before it has actually finished all the required steps. In some cases, the models even hallucinated extra steps or skipped over necessary ones entirely. Interestingly, model size helped, but it was not a perfect fix for these procedural errors. Even massive models with hundreds of billions of parameters showed consistent declines as the tasks got longer. The study also looked at how different types of math affected the models. Addition and subtraction were generally easier for the AI to track than multiplication or division. However, when the tasks were mixed together, the models became much more likely to lose their way. This suggests that switching between different types of logic is a specific weakness for current AI. Let's recap the most important takeaways from this diagnostic study. First, final answer accuracy is often a mask that hides an AI's inability to follow a sequence. Second, memory or the ability to look back at previous steps is a critical bottleneck for reliable reasoning. Third, the tendency for AI to stop early or skip steps is a major barrier for professional applications. These findings mean that for complex workflows, users cannot yet fully trust AI to operate without human oversight. For the future, this research points toward a need for better training on procedural faithfulness. Developers may need to focus less on just getting the right answer and more on the process used to get there. Understanding these limits helps the industry build more robust and dependable AI systems for the real world. Thank you for watching Summarize Science, and stay curious about the world of technology.